Okay, so in the final lesson of the financial unit, we are going to be looking at present day value when it comes to annuities. So similar to what we did when we did the compounding unit and we looked at present value, the way one, it's still an annuity, so you know you're dealing with an annuity problem when you're talking about regular deposits or regular withdrawals. Okay, so something's happening on an interval, right? Like series of regular payments, right? Like that's that word I'm looking for. So if something's happening on a set time, set interval, like money's going in or out at regular intervals, you know you're dealing with an annuity. Now, how do you know if it is a present value problem or if it's a future value problem? Okay. Well, that really just comes into the language that is being used in terms of saying the word now, right? Or financed now. So if you ever see this word now or like currently or time being zero, right? Like it's just what is happening like in the before. So like what would have to happen before or the now. These are words used for present value, okay? So let's just look at a problem, it will make sense. Example one, Mary has money in an account that pays 9% compounded annually. 1 year from now, he will, or she, I guess, she will go to college. While Mary attends college, the annuity must provide her with four equal payments of $5,000 for tuition. How much should Mary invest now if the first payment starts in a year? So again, this word invest now, like key thing being now, that tells you you're dealing with a present value problem. All right. So you know it is going to be a annuity problem for equal payments. All right. So while Mary attends college, an annuity. All right. So an annuity is a type of like an account, whatever, that just pays you out, but must provide four equal payments of 5,000. So these are regular interval payments that are recurring. All right. That's how you know you're dealing with an annuity problem. Okay. Let's Otherwise, it's so similar to the previous one. You have an equation. You are not expected to memorize this, okay? So you just have this equation. It looks near identical to the previous one. Just careful, you have this negative exponent here. So from our exponential unit, just know how you deal with that negative exponent and careful plugging it into your calculator, okay? So you still have your R value in your equation. That is the regular payments, or so in this case, in the example, that was the $5,000, right? So the R is the $5,000 that's in this example. That's the money that needs to be paid out. All right. We are looking for present value. I already said that. The interest rate, same thing that you do always. You have to take your interest rate in percentage. So it tells us it's 9%. So put that in a decimal. That's 0.09. And you need to divide that by your number of compounds. So it's compounding annually. So that just means it's being divided by 1. So nothing happens. It's still 0.09. And then n is your time frame times your compounds. So the time frame in this case, well, let's look. Mary attends college. You must pay four equal payments of 5,000 for tuition. Four equal payments for tuition. Okay, so that's a 4-year college, right? Like you pay tuition every 4 years. So I mean, I guess it could be every tuition's every semester, but let's assume T is 4. Okay, so 4 years of coming out. So we are looking for T value times number of compounds again, number of compounds. We're going to assume that the payments go every year. So 5,000 would be 4 years times 1, so n is 4. Okay, set up your formula. The present value is equal to R, and actually I need to go and look at 1 minus 1 plus I to the power of negative n all over I. Okay, so we're looking for present value. Your R in this case, we said, was 5,000. So 5,000. Multiplying that by 1 minus 1 plus your interest rate, which is 0.09, all to the power of minus 4 in this case. Careful, minus 4. All divided by I. Oh, sorry, I is 0.09. Okay, so we have 5,000. Now clean up that bracket. So I'm actually going to evaluate this on my calculator first. So again, careful putting the calculator. That's 1.09 to the power of -4. So I got 1 minus, and then if I did that 1 -4, try it on your calculator, you should get 784 roughly, okay? Dividing that by 0.9. Oh, I don't know why I started writing in pink, but so we have 5,000, and then 1 minus that answer, times that by 5,000. So up top, you will have 1,457.87, all divided by 0.09. So your final answer, your present value, would be that number divided by 0.09. I get $16,198.60 after rounding. Okay? So how much should Mary invest now? Well, in order to have $5,000 payments coming out every 4 years, you need to have $16,198 set in the account. All right. Stephen has set up an annuity to help his son pay living expenses over the next 5 years. The annuity will pay $50 per month, or $50 a month. So again, a regular withdrawal of $50 is happening. So you know it's an annuity. Even though it says annuity here, you just know that it's also annuity from that. Okay? So the first payment will be made 1 month from now. The annuity earns 7.75% compounded monthly. So this tells you 12, okay? So how much money did Stephen put in the annuity? So what is the present value? What is the amount that is required right now so that for the next 5 years, $50 a month can come out, okay? So $50 a month coming out, well, that's your R. You have $50 needing to be withdrawn a month. And again, remember that whole thing about interest rate and the whole per month thing? These right here, right? Like these have to be the same. The withdrawal or the deposits need to happen on the same interval that the compounding is occurring at. Okay? That's what simple annuity means. All right, so we have our interest rate. Our interest rate was this right here, 7.75%. But put that in a decimal, that's 0.75, and divide that by your compound, your 12, right? So again, this right here is 7.75%, and this is the monthly, right? So there's 12 occurring per month, or per year, 12 months in a year. So 0.075, divide that by 12, you get 0.00625. And then N, in this case, is we need it for 5 years. So again, that's your T. Your T is 5. So you have 5 being multiplied by 12, your compounds, you get 60. So the problem is saying how much we'll put in the annuity. So that's your present value. So the present value in this case is equal to R times 1 minus 1 plus I to the power of -n all over I. So if we do now plug in everything that we have R being $50 needs to come out every month. That is now 1 minus 1 plus the interest rate we have is 0.00625. Okay. And then we have to the power of -n, so minus 60. There's 60, yep, minus 60. All over the interest rate of 0.00625. So it's just a calculator problem at this point. So again, just practice with the calculator. So I'm going to go 1.00625 to the power of -60, right? So in this case, I would have 50 being multiplied by 1 minus 0.688 0.09, and then that is all being divided by 0.0625. So again, clean this part up first. So 1 minus that. I multiply that by 50 and divide that by 0.00625. So I get 2,495 and 27 cents. So how much does he need to put in the annuity? Well, that is how much Steven needs to put in the annuity, okay, in order to be able to pull out $50 per month. How much interest will the annuity earn over its term? Okay, so again, how much interest? The only thing that's earning you money is interest. So essentially, the interest is equal to, well, how much money needs to be put in, so, or your future value, your annuity, minus your present value. Your present value. So in this case, what you need to figure out is how much needed to be, how much was put into the problem. So we know that this is minus, the present value is minus 2495.27. But what is this? What is, sorry, no, why did I say annuity? This should be future. So what is this right here? What is the future value? Well, that's essentially what is the value of the money? Well, the value of the money, the future, is the value of the money is you're taking $50 a month, right? And that's happening how many times? Well, that's happening 60 times, right? Because you have 5 times 12, right? 5 years, and there's that many months. So there's 12 withdrawals every 5 years. So essentially, you were withdrawing $3,000, right? So you're withdrawing $3,000. So what is that difference? How did you earn $3,000 from your initial 2495.27? That's the interest. So 3,000 minus 2495.27. Well, that means you would have earned $504.73 in interest, right? Because you started with 2,400 or 2,500, and you earned 3,000. You had $3,000 worth of those $50 payments that came out. All right, example 3. Christina bought a bicycle for $1,500. And sorry, I had to make a break in the video. I made a small mistake that I made at the very beginning of the question, and I just went through the whole question. And I realized my mistake, so I'm just editing it, doing the question over again. The mistake was I just simply didn't put this into decimal format. So very easy to make mistakes. I make mistakes, so please learn from my mistakes. Christina bought a bicycle for $1,500. She arranged to make a payment to the store at the end of every month for 1 year. The store is charging 11% interest compounded monthly. Okay, so let's decipher what this question is asking and how much is each monthly payment. So how much is each monthly payment, right? That's the regular, it's saying what is your regular withdrawal or regular given. We are looking for the R value, right? So we will have to rearrange that formula for R. And let's pull apart all the other pieces of information given. So this 11%, right? So our I in this case is 11%. And we need to divide that by our number of compounds. Well, it's compounded monthly. So that's 12, right? So this would be divided by 12. Or 0.11 divided by 12. Or that would give you, 0.11 divided that by 12. That is 0.0091667 essentially. Your N is how long and how many what's the long this experiment is going for? Well, every month for 1 year. So the total thing is happening across 1 year. That's your time. Your T is 1. And how many compounds? 12. You have to make 12 regular payments. So times 12. So N is 12. And then your present value. Well, she bought the bicycle for $1,500. So that's your present value. Your present is $1,500. So PV is $1,500. So if we have our formula, which is PV is 1 minus, R times 1 minus 1 plus I to the power of negative n all over I. Let me just double check that so I don't make a mistake. Yep. Okay. So present values are 1 minus 1 plus I to the power of negative n over I. Rearranging this for R, so the first thing we need to do is get rid of this I on the bottom here. So you'd be multiplying both sides by I, right? So you'd have PV multiplying by I is equal to, these cancel, R over 1 minus 1 plus I to the power of negative n. And now divide both sides by the square bracket. 1 minus 1 plus I to the power of negative n. On both sides, make sure you do that. So 1 minus 1 plus I to the power of negative n. These cancel. And now you have your formula rearranged for R. So it's PV times I all over 1 minus 1 plus I to the power of negative n. So at this point now, just substitute your known values in. So the present value, she bought a bicycle for $1,500. The interest rate being applied is 0.0091667. On the bottom, it is 1 minus 1 plus 0.0091667, all to the power of n in this case was 12, so negative 12. All right, so clean up the numerator. So let's go 1,500 times that amount, 1,500 times that interest rate. So up top here, we would have 1375. And then on the bottom, we will have, well, 1 plus 0.00916667, all to the power of negative 12. So, and then I have 1 minus that answer. So on the bottom, I would have 0.1037. And then 13.75 divided by that amount, I would have to make, or she would have to make $132.57 payments, okay? So that's what would have to be coming out of her account in order to be able to afford that $1,500 bicycle. But how much of that $132 represents interest? So like, what is the cost of not paying it right out of the way and just having to use this whole financing method? Well, again, interest is your future, like what the value is what you've actually paid minus the present. So in this case, our present value, we had the bicycle. The bicycle is worth $1,500. That's a sticker price. But the future, well, the future is this right here, is this amount times how many times you have to do that, right? So your future in this case was your $132.57, and you had to do that 12 times, right? You had to make 12 payments. So the total amount that you actually put out was, times that by 12, was you had to put out 1,590, or Christina, she had to put out 1,590 and 87 cents. So the amount that was owed was 1,590.87. So the cost of borrowing, right, that's what that interest is actually $90.87. That's what it costs you. Instead of buying the bicycle outright, if you want to finance it, you have to pay that extra little bit, okay? So that is our final lesson, and there's a homework. I will see you in class.